Good morning everyone. So this is Mrs. Antony again. Today we are going to do acid content in orange juice. So far in lessons we have looked through acid-base titrations. We've looked at acid-base titration between sodium hydroxide and hydrochloric acid, and in those cases we have used an indicator to let us know the end point of that titration. As you know, in titration we are trying to find concentration of one substance, having understood that the concentration of the other is provided. In your mind, if you think of orange juice is colored. So when you have colored substances, it is not so useful to use an indicator which changes color in acid and bases, because the juice itself is colored. It's not going to help you to find the equivalence point or the end point. Hence, we look towards something else, which is a pH of the solution. So orange juice has acidic content in it, and you are going to use a weak sodium hydroxide, which is around a 0.1 molar sodium hydroxide, and then determine what amount of acid is present in it. Once you know the amount of acid that is present in it, considering you know the volume of the orange juice that you have taken initially, you will be able to calculate the acid content in it. Alright, let's get going. Starting off with the burette. So we put the titrant here, which is sodium hydroxide, as I just said. I have taken sodium hydroxide in the speaker. What we are going to do first is, as usual, I have rinsed it with distilled water. Now I'm going to rinse it with sodium hydroxide. Now we fill it up with sodium hydroxide. So you have your waste beaker here, and you make sure that the meniscus is resting at 0. Now the next step is you need to take the mass of the orange juice. So we've got an orange juice, golden circles, delicious, and we'll find out how much acid is present in that. So let's wait. Tare the balance. So the method says around 20 grams. We have got a mass of 29.96, but that's okay, we'll just use that. Alright. So we are asked to top it up so that we can ensure that the pH probe is completely in it. Okay, we'll just rinse that off, and now we are going to immerse it. If you look at the pH, at the moment it is sitting at 3.6. What I'm intending to do is, I will add an ml of the sodium hydroxide, and then I'll check the pH again. Okay, that's about a ml. And I'm just going to give it a little swirl there, so it's completely stirred, and the pH has gone up slightly, so it's gone from 3.6 to 3.66, but that's not enough to show us that the sodium hydroxide has actually neutralized the acid in it. It's still acidic. So we've moved forward, we still continue our titration. So we can safely assume that it has plateaued and we have got an equivalence point here. The graph that we have got at the moment, I'll need you to analyze it and have a look at the different features of that graph and determine the equivalence point from it. Okay, looking at the graph, we were able to find out that the equivalence point was around 28.20 mils. I'll let you figure out how we are able to find it from your reading and from discussions with your partner. And I'll write it down on the board at the moment. Following this, we have done another titration as well, and the equivalence point for that was found to be using the average obtained from these two titrations. I'm expecting you to calculate the acid content in the orange juice, discuss among yourself, and then figure out how will you determine this if you know the mass of the orange juice given. Thanks for watching, and make sure you complete all the questions at the end of the experiment. Thank you.